Imagine shattering your smartphone screen and watching as the glass fragments melt away, reforming into a pristine, flawless sheet. This isn't science fiction. It's the incredible journey of glass, from sand to screens. Glass is all around us, from the windows in our homes to the screens on our smartphones. But have you ever wondered how it's made? The journey from sand to glass is a fascinating process that involves transforming raw materials into a versatile and essential material. The primary ingredients in glass production are silica sand, soda ash, and limestone. Silica sand, rich in silicon dioxide, provides strength, durability, and transparency. Soda ash, or sodium carbonate, acts as a flux, lowering the melting point of silica and making the process more energy efficient. Limestone, or calcium carbonate, stabilizes the glass structure, ensuring it's durable and resistant to water. The glass manufacturing process. The glass manufacturing process involves several stages, from raw material preparation to the final product. Here's a detailed overview of the process. 1. Batching and mixing. The first step in glass manufacturing is batching and mixing. The raw materials, including silica sand, soda ash, and limestone, are carefully measured and mixed to create a uniform blend. This mixture, known as the glass batch, is then prepared for melting. The quality of the raw materials is crucial, as impurities can affect the final product's clarity, strength, and durability. Some manufacturers also add recycled glass, known as cullet, to the batch to reduce waste and energy consumption. Raw materials. Silica sand, soda ash, and limestone are the primary raw materials used in glass manufacturing. Other materials, such as colorants and clarifiers, may also be added to the batch. Cullet. Recycled glass, or cullet, is added to the batch to reduce waste and energy consumption. Cullet can be obtained from various sources, including post-consumer waste and industrial scrap. 2. Melting. The glass batch is then heated to extremely high temperatures, typically around 1,500 degrees Celsius, in a furnace. This process transforms the raw materials into molten glass. The furnace is typically fueled by natural gas or electricity, and the melting process can take several hours. The molten glass is then stirred to ensure uniformity and remove any bubbles. Furnace types. There are several types of furnaces used in glass manufacturing, including regenerative furnaces, recuperative furnaces, and electric furnaces. Each type has its own advantages and disadvantages. Melting process. The melting process involves heating the glass batch to a high temperature, typically around 1,500 degrees Celsius, to form molten glass. The molten glass is then stirred to ensure uniformity and remove any bubbles. 3. Forming the molten glass is then shaped into the desired form using various techniques, such as blowing. Molten glass is inflated into hollow shapes using a blowpipe. This technique is used to create bottles, jars, and other containers. Molding. Molten glass is poured into molds to create precise shapes. This technique is used to create complex shapes such as laboratory equipment and decorative items. Rolling. Flat sheets of glass are formed by rolling molten material between metal rollers. This technique is used to create flat glass for windows, doors, and other applications. Float glass. Molten glass is floated onto a bath of molten tin, where it spreads out and forms a flat, smooth sheet. This technique is used to create high-quality flat glass for architectural and automotive applications. 4. Annealing. The glass is cooled slowly and carefully to prevent stresses and breakage. This process, known as annealing, ensures the glass is stable and durable. The annealing process can take several hours or days, depending on the thickness and type of glass. Annealing process. The annealing process involves cooling the glass slowly and carefully to prevent stresses and breakage. The glass is typically cooled in a controlled environment, such as an annealing oven. Importance of annealing. Annealing is a critical step in the glass manufacturing process as it ensures the glass is stable and durable. Improper annealing can lead to stresses and breakage in the glass. 5. Finishing the glass is then cut, ground, and polished to achieve the desired shape and finish. This can include additional processes such as grinding. The glass is ground to remove any imperfections or sharp edges. Polishing. The glass is polished to create a high-gloss finish. Coating. The glass is coated with a layer of material, such as a reflective coating or a low-E coating, to enhance its performance. Techniques used in glass forming. In addition to the techniques mentioned earlier, There are several other methods used in glass forming, including pressing. Molten glass is pressed into a mold using a machine. This technique is used to create complex shapes, such as cookware and laboratory equipment. Centrifugal casting. Molten glass is spun into a mold using a centrifuge. This technique is used to create cylindrical shapes, such as pipes and tubes. Applications of glass. Glass is a versatile material with a wide range of applications, including architectural glass. Glass is used in building construction for windows, doors, and facades. Automotive glass. Glass is used in the automotive industry for windshields, side windows, and rear windows. Consumer products. Glass is used in a variety of consumer products, including bottles, jars, and cookware. Laboratory equipment. Glass is used in laboratory equipment, such as beakers, flasks, and test tubes. In addition to the techniques mentioned earlier, there are several other methods used in glass forming, including pressing. Molten glass is pressed into a mold using a machine. This technique is used to create complex shapes such as cookware and laboratory equipment. Centrifugal casting. Molten glass is spun into a mold using a centrifuge. This technique is used to create cylindrical shapes such as pipes and tubes. To ensure the quality of the final product, glass manufacturers implement rigorous quality control measures. This includes visual inspection. The glass is visually inspected for any imperfections or defects. Testing for strength. The glass is tested for its strength and durability using techniques such as impact testing and thermal shock testing. Testing for clarity. The glass is tested for its clarity and transparency using techniques such as spectrophotometry. Testing for durability. The glass is tested for its resistance to weathering and chemical attack using techniques such as accelerated weathering testing. The glass industry is increasingly focused on sustainability, with efforts to reduce energy consumption and waste. Some of the initiatives include recycling. Recycling glass reduces the amount of raw materials needed and saves energy. Cullet, or recycled glass, can be added to the glass batch to reduce the melting temperature and energy consumption. Energy-efficient furnaces. Modern furnaces are designed to be more energy efficient using technologies such as oxy-fuel combustion and regenerative heating. Reducing waste. Manufacturers are implementing measures to reduce waste, such as recycling glass waste and minimizing packaging. By understanding the glass manufacturing process and the various techniques used, we can appreciate the craftsmanship and technology that goes into creating the glass products we use every day. Your input matters. Share your ideas for our next video in the comments, and we'll recognize your contribution. Thanks for joining us on this exploration of the fascinating stories behind everyday things. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching, and if you want to learn more, click the next video right here.